So, falsifiability and falsification. What are these things and why are they important? Well, falsifiability shows up in a lot of places as an important standard for determining whether something is scientific or pseudoscientific or non-scientific, whether it is in school textbooks or internet debates. The story kind of goes like this. Statements that are falsifiable are scientific, or at least possibly scientific, and conversely, if a statement is not falsifiable, by which I mean if a statement cannot be disproved on the basis of evidence that you confront that statement with, then it couldn't possibly be scientific. So falsification or falsifiability becomes the standard of demarcation for sorting science from non-science. This is very appealing, of course, because it means that your standard for whether something is scientific is whether you can confront it with real world data and then prove or disprove it. More specifically, disprove it. But there are some problems with falsifiability as a demarcation criterion, some big ones. The first and probably most profound set of problems are logical, namely that you never actually falsify claims in isolation because there is no pre-theorized body of data. There's no sort of body of information that isn't itself constructed on the basis of all kinds of theoretical assumptions. Let me put this a little bit less abstractly for a moment. Imagine that you're a scientist and you're conducting an experiment. Okay, so your experiment has yielded data that appear to disprove your theory. Is that theory done and dusted? Well, not quite. So in order for your data to be treated as falsifying, you have to assume that your scientific instruments were working properly. Perhaps the truth of the matter is that your machines just weren't working right, and so the data you have is garbage. You have to also assume all kinds of methodological standards for determining whether something passes the threshold of falsification, right? So in the social sciences, you'll often see p is smaller than 0.05 as the standard for statistical significance. Well, that's a little bit arbitrary, isn't it? Because in different fields, that standard would be usually much smaller, right? So in order to treat something as falsifying, you have to have it rest on all these other assumed standards or conditions, and those things are not being subject to falsification. At the logical level, what this means is that you never falsify statements in isolation. What you do is determine whether within a web or a system of knowledge claims there's some kind of inconsistency, something isn't right. And then on the basis of your various assumptions, you determine whether what isn't right is your data, what isn't right is your theory, your instruments, etc. This on its own, as I said, is a pretty major logical problem for falsification as an account of science. But there's more. Scientists themselves don't really go about doing science according to the falsificationist program, right? Like scientists themselves don't usually go around looking to disprove their theories. Moreover, there are plenty of scientific theories that we would say are fairly successful, like biological evolution, like plenty of geology or taxonomy in the life sciences, and these things don't appear to be falsifiable. In fact, Karl Popper, the philosopher most famously associated with falsification, thought evolutionary theory was metaphysics, that it wasn't science. But this seems wrong, or to put more bluntly, this seems kind of daft, right? If scientists are going about calling themselves scientists and doing work that we admire, and yet what they're doing doesn't pass our test for whether something is science, then probably the test itself is a problem rather than the scientists. Moreover, plenty of bullshit like young Earth creationism or astrology can be formulated in falsifiable terms. What this shows is that falsification isn't merely logically flawed, it's also, as a practical matter, just not a suitable demarcation criterion. It doesn't actually neatly divide science and non-science, since it excludes some things that we probably do want to call science, and it admits a bunch of things that we probably don't. Well, where does that leave us? Does that mean that the idea of falsification is completely useless? No. So there's kind of a softer version of that claim, and it goes something like this. When you formulate statements about the world, when you build your theories about how things are, whether you're trying to be a scientist or not, you should do so in a way that is conscious of the circumstances under which they could be wrong. You do so conscious of when those theories or when those ideas about the world cease to be useful, when they cease to adequately capture or account what's going on around you, when they cease to be helpful cognitive instruments. This isn't quite the same as falsificationism or falsifiability as a neat, logically sound criterion that helps you determine whether something has been properly disproven or whether something is amenable to disproof in the first place. But it does retain some of the rational benefits that falsificationists were trying to get at. Thanks a lot.